right, so at this point we're warming up to get to the completing the square method. So this is just kind of a little warm up, a technique that we want to practice to be able to do that. So we're still solving quadratic equations ultimately. So right now what we're going to do is we're going to just be looking at quadratic expressions, and we're going to be trying to create what's called a perfect square trinomial. So what we're looking at here, we've got x squared, oops, let me activate that pen. We've got x squared plus 4x, and then we want to turn this into a trinomial. So we're trying to figure out which constant to add to create a trinomial that's what's called a perfect square trinomial. So it's a special type of a three-term polynomial, a trinomial. So as you get more practiced at this, you won't need to go through all these acrobatics necessarily. You might just be able to do this quickly in your head. But for now, what we're doing is we're going to take our b coefficient, we're going to divide it by 2, and we're going to square it. And that's how we know what to add as our constant. So we've got, in this trinomial, a equals 1, b equals 4, and we're trying to figure out what we want c to be. So we're going to take, let me make this bigger so I can write in here. We're going to take b, divide it by 2, and square it. So b divided by 2 squared, in this case, is equal to 4 divided by 2 and squared. 4 divided by 2 is 2 squared, which gives me 4. So I'm going to add 4 to both sides. And then it asks me for the factored form. So we've got x squared plus 4x plus 4. And if I went to factor this trinomial, I would factor it as x plus 2 times x plus 2, right? 2 times 2 multiplies to 4. And 2 plus 2 adds to positive 4, right? So x plus 2 times x plus 2. But of course, another way to write this would be x plus 2 squared. All right, x plus 2 squared, that's what we mean when we're talking about a perfect square trinomial. So when we factor our trinomial, we get one single factor squared. And I just want to point out that even though this was a pretty doable factoring problem, when we do this b divided by 2 step inside our parentheses, 4 divided by 2 is 2 inside the parentheses before we square it. That's always going to be what appears in your factor. So as these get more difficult, you can maybe use that as a little trick. Okay, let me change the pen color. So down here below, we've got x squared plus 6x plus, and then we want to figure out what constant to add. So I'm going to take b, which is 6. I'm going to take 6, divide that by 2, and square it. 6 divided by 2 is 3. I'm going to square 3, which gives me 9. So x squared plus 6x plus 9 is a perfect square trinomial. When I go to factor it, I would factor it as x plus 3 times x plus 3, also known as x plus 3 squared. And again, notice 6 divided by 2 in parentheses equals 3 before I square it. I have a 3 in my factored form, x plus 3 squared. So you can use that if you need to, if the factors get a little bit tricky. All right, next up, x squared minus 4x. So now we've got a negative b coefficient, right? b equals negative 4. So I'm still going to take, I'll just do this up here so I don't run out of room, negative 4 divided by 2 and square it. Negative 4 divided by 2 is negative 2. I'll square that. Negative 2 in parentheses squared is positive 4. So notice that we're always adding a positive constant. All of these perfect square trinomials will have plus a positive constant at the end, even if you have a negative for b. And when I go to factor this, it would factor as x minus 2 times x minus 2, also known as x minus 2 squared. And once again, notice that when I took negative 4 divided by 2 inside the parentheses, I got negative 2. The negative 2 appears in my factor. All right, x squared minus 10x. b equals negative 10. So I'm going to take negative 10 divided by 2 and square it, which is negative 5 squared, which gives me positive 25. So I add 25. And then my factored form, x minus 5 squared. The negative 5 from dividing by 2 is the negative 5 that appears in my factored form. All right, so this is all a warm-up to actually complete a completing the square problem. So these are the steps that we're going to follow. So we have a quadratic equation. Step 1, we're going to rewrite the equation with all the variables on one side in descending order and the constant on the other side. So looking at number 7, let's go ahead and do step 1 first. So I want to get the constant on the other side. So I'm going to start by subtracting 2. So this gives me x squared plus 4x equals negative 2. And I'm going to leave a little space there because I know I'm going to add a constant in just a minute. Step 2 says divide by the coefficient of the squared term if it is not 1. The coefficient of our x squared is 1 in this case, so we don't have to do this step. We'll see this in later examples. Step 3, complete the square by taking the middle term and dividing by 2, square it, and add this number to both sides of the equation. So this is where we do the b over 2 squared step. We add it to both sides of the equation. So in this example, b is 4. So I'm going to take 4, divide it by 2, and square it, which is 2 squared, which gives me positive 4. So I'm going to add 4 to both sides of the equation. So plus 4 and plus 4. All right, step 4, factor the one side as a binomial squared, simplify the other side. So on the left side, I'm going to factor as x plus 2 squared. On the right side, negative 2 plus 4 adds up to just positive 2. And then for step 5, I'm going to solve using the square root method. That's my plus or minus method. So from here, I can take the square root of both sides, but this is where I'm going to tack on the plus or minus. X plus 2 equals plus or minus square root of negative 2. And then to solve for x, I subtract 2 from both sides. So this gives me x equals negative 2 plus or minus square root of 2. All right, now I know some of you just watched that example and you're like, why is this crazy lady solving this in this manner? Just use the quadratic formula. And you're totally right. The quadratic formula would get us the same exact answer and it would get it to us much, much quicker. So why are we doing this? The completing the square method, I'm going to let you in on a little secret. It is not very efficient to use. Okay, it's not very efficient to use, just being straight with you. The reason we use completing the square now is we're going to be using completing the square techniques later on when we're dealing with circles and parabolas and other types of nonlinear equations. So we're practicing using completing the square now so that when we see it later, it won't seem so scary.